Hello everyone, I am Amanul before you, a PhD student in security under the Department of Computer Science. Today I will present my current research paper in anomaly detection in 5G 6G networks, a survey in machine learning techniques. What's in this research presentation? The first we will talk about research goal, then research gaps, then motivation, then categories of anomalies, then machine learning in anomaly detection, then challenges in 5G 6G anomaly detection, then prominent techniques, then application and uses, and then comparative analysis, then categorization of previous results in anomaly detection, future directions, and finally conclusion. So what's our research goal? So 5G and 6G networks offer ultra-fast speeds, low latency, and improved device connectivity for unprecedented performance. And as a result, rapid technical advancements expose next-generation networks to diverse security threats, necessitating robust protective measures. That's why anomaly detection is crucial in identifying deviations from normal behavior, enhancing security protocols in networking infrastructures. So what's the research gap? So before going to dive into the other slides, we want to talk about the research gap. What's the research gap in anomaly detection in 5G 6G networks? First one is lack of real world database. Current anomaly detection research for 5G 6G suffers from insufficient real world datasets for model validation. Second one is scalability challenges. Existing models struggle with scalability in larger dynamic environments, hindering their practical application and effectiveness, and real-time application issues. Adapting to anomalies in real time remains a significant hurdle, completing timely responses and threat management. So what's the motivation for anomaly detection in 5G 6G? Advancements in 5G and 6G create new attacks vectors, increasing the network's vulnerability to intrusions. Conventional detection techniques often fail against sophisticated attacks, lacking adaptability to evolving anomalies in networks. That's why the complexity of modern networks necessitates innovative anomaly detection methods, utilizing machine learning for enhanced security. So, our research is about anomaly detection in 5G 6G. So first we need to categorize of our anomalies. So here we are categorized our anomalies in two ways: network intrusion and spoofing techniques. So network intrusions involve unauthorized access to 5G 6G networks, compromising data integrity and privacy through various techniques. And spoofing techniques is methods like face stations mislead devices, allowing attackers to intercept data or manipulate connections. So machine learning in anomaly detection. So why we use machine learning in anomaly detection? Because machine learning enhance anomaly detection through supervised, unsupervised, and semi-supervised methodologies tailored to network environments. So what is supervised learning limitations? So supervised techniques require level data, which is often scarce in dynamic networks, limiting their effectiveness rapidly. Otherwise, unsupervised learning models automatically identify anomalies, adapting well to the fluidity of evolving 5G and 6G environments. And other method is semi-supervised methodology, where we combined the semi-supervised learning method and unsupervised learning methods to detect anomalies in 5G and 6G networks, which is also very useful for anomaly detection in 5G 6G, better than supervised learning methodologies. So what's the challenges in 5G 6G anomaly detection? So first one is dynamic network topologies. Rapidly changing topologies in 5G 6G complicate detection due to frequent shifts in network configurations. Another one is real-time data management. Handling high data volume in real time poses challenges for effective anomaly detection and timely responses. Another challenges issue is high false alarm rates. High rates of false alarms undermine trust in detection systems, leading to potential security oversights. So, what's our prominent techniques to detect anomalies in 5G 6G? Because without good techniques, we can't detect anomalies or flags anomalies from the 5G and 6G networks. It will be tough for us. So these are some techniques which is very prominent for anomaly detection. First one is clustering techniques. Clustering techniques. What is clustering technique? Clustering techniques group similar data, aiding in detecting anomalies through unsupervised learning approach effectively. Another one is deep learning approaches, which is very powerful techniques for anomaly detection. And in deep learning approaches, autoencoders and LSTMs excel at identifying complex patterns in temporal data, enhancing anomaly detection accuracy. Another one is hybrid models, which is also very very fast and very powerful to detect anomalies in 5G and 6G networks. So combining machine learning and deep learning methodologies and enriches the anomaly detection process and improving robustness significantly. So these three techniques will help us to detect anomalies very efficiently. So these are the very prominent techniques for us. So later we need to know what's the application and use cases of these anomaly detection techniques. So there are many sectors in our industries. The first one is telecom infrastructure applications. The anomaly detection enhances continuous operation in telecommunications, preventing service disruptions and safeguarding user data integrity. Another application and use cases are blockchain security enhancements. In blockchain, it mitigates unauthorized transactions in blockchain applications by detecting unusual patterns crucial for maintaining system trust. And another one is cryptocurrency fraud prevention. So in cryptography fraud prevention, by identifying anomalies, systems can thwart fraudulent activities, protecting market stability and enhancing user confidence. So comparative analysis. So what is the comparative analysis? Comparative effectiveness. So machine learning offers adaptability, while deep learning excels at complex pattern recognition for anomaly detection. Unauthorized model advantages. So unsupervised method advantages. Unsupervised methods automatically learn patterns, crucially aligning with the dynamic nature of 5G and 6G environments. Suitability for evolving networks. The evolving characteristics of 5G, 6G necessitate detection techniques that can continuously adapt without prior levels. So in our research, we categorize our anomaly detection technique in this category. The categories are detection methods, application domains, data type, and application algorithm complexity. And detection method, and every categories we divided with one or two subcategories. Though in detection methods there are two subcategories: machine learning methods and deep learning methods. And in the selected papers we mentioned the papers regarding these machine learning methods and deep learning method. In application domains, it is divided into two categories: telecommunication and cryptocurrency security. And in the selected papers column, we are seeing that the selected papers which we categorize are mentioned here, and data type are subcategorized into two ways: structured data and time series. So structured data and time series. And in the selected papers we see that the papers which we categorized in data type are mentioned in this column, and application complexity is subcategorized in only one part, is high complexity algorithms. And these are there are 5 papers we got from our previous research. And in this bar chart, the bar chart illustrates the count of reviewed papers classified into different subcategories of enemy detection methodologies across 5G 6G networks. The subcategories include machine learning methods, deep learning methods, telecommunications, frequency security, structured data, time series, and high complexity algorithms. And in the every part, you are seeing that the number of papers which we reviewed in every subcategory are mentioned in the peak of the bar. So we categorize 50 papers, reviewed 50 papers in our research, and these are the number of papers and the subcategories which we got from this research are mentioned here. So these are the future directions. So we subcategorize and we got applications, domains, and we got use cases where we can use our 5G 6G enemy detection networks, and which machine learning techniques and deep learning techniques are important in our enemy detection in 5G 6G networks are we got from this research, from this review paper. So after this review, we can after this review we will go for future directions where we can improve this paper in future, and how we which fields we can emphasize in future research, and which we can include in our research in future papers. So future research should focus on adaptive unsupervised models that dynamically learn from network behavior challenges, because in supervised models it is level data, and also sometimes we need to fix the threshold, but in unsupervised learning model we can dynamically learn from network behavior changes. And another one is explainable AI. Incorporating explainable AI can enhance detection capabilities by providing transparency in model detection decision making processes. This is a new field in machine learning, explainable AI. And another one is real-time detection mechanisms. So this is another future direction for us to improve the paper, and developing real-time low latency detection mechanism is essential for effective anomaly responses in modern networks. So finally, we will conclude our research paper in anomaly detection in 5G 6G, a survey of machine learning. So in our ongoing innovation in anomaly detection techniques is vital for safeguarding 5G and 6G networks against threats. Effective threat management in evolving network landscapes demands continual enhancements of detection methodologies and systems, and investment in research are crucial for developing advanced solutions that address the unique challenges for next generation networks. So thank you for hearing my speech in patience.